In our last video, we looked at standardizing z-scores so that we were going from just any normal distribution to the standard normal distribution. In this chapter, in this section, we are going to be finding probabilities using some of that same information. So let's take a look at the following problem. Robin plays basketball and has a scoring average of 22 points a game with a standard deviation of 4 points. We want to assume that Robin's scores are normally distributed. We're going to answer 4 questions. First one, what is the probability that Robin scores less than 20 points in the next game? Now, when we have a normal distribution and we're looking for probability, the first thing we should think is z-score. So let's do our z-score, letting x be these 20 points that he has in the next game. Our average, our mean mu is 22, and our standard deviation sigma is 4. So let's plug that into the z-score that we've already been doing. So we will have 20 minus the mean of 22 divided by 4. And on top, that gives me negative 2 divided by 4, which is negative 0.5. Now, in the last set of exercises, we used the empirical rule, but we got z-scores that were like -1, -2, +3. They were all nice round numbers and not decimals like this, so we could use the empirical rule. When we get things in between those nice round numbers, however, we need a table that's going to tell us what this probability is. And we're going to use a standard normal table. Now, when you're doing this in the homework, they're going to show you just part of the standard normal table, but I'm going to pull it up. It looks like this, and at the top, you'll notice there's a picture of a normal curve, and then they have the left side of that normal curve shaded. And that's because anything we look up on this table is giving us the probability of something being less than whatever z-score we're looking up. All right, now we got a z-score of -0.5. So we're going to search on our table. Notice here's the z-score column, and we're going to find -0.5, which is right here. And if I look across from -0.5, there are two things. There's a percentage and there's a probability. And those two are essentially the same thing, except when the problem asks for percent, we want to report this 30.85%. When it asks for probability, we want to report the decimal, 0.3085. So let's go back, 0.3085. Now, notice that our problem asked, what is the probability that Robin's scores are less than 20 points in the next game? And I said the standard normal table gives us the probability that something's less than our z-score. So we're actually done with this question. The probability that he scores less than 20 points is 0.3085. Or if we think of that as a percentage, 30.85%. All right, now, let's take a look at the next one. What is the probability that Robin scores more than 20 points in the next game? Now let's notice that it involves the same x value we've got back here, so we don't have to redo our z-score. We're going to get exactly the same thing if we were to plug in. However, this is asking for the probability that he scores more than 20 points. Not less than, like we got back here. To get more than, we always have to take our table and look up what we would get for less than, which we already have the answer to right here. But for more than, to get the probability of more than, we subtract that number from 1. So if we subtract 1 minus 0.3085, we are going to get a probability of 0.6915. So notice, less than, we do our z-score, we look it up on the table. More than, we do our z-score, we look it up on the table, but then we subtract it from 1. And then, let's look at our next one. What's the probability that Robin scores between 18 and 20 points in the next game? Now, in this case, we really have two x values. We have an 18 and we have a 20. We are actually going to do z-scores for both of them. Now, we already have done a z-score for 20. That's that same z-score we got back here in parts 1 and 2. So I'm going to go ahead and write down that z-score. And out to the side, I'm also going to put that probability we got when we looked it up on the table. But let's go ahead and do the z-score for the other x value, for the 18. So we're going to take 18 minus our mean of 22 and divide it by our standard deviation of 4, which gives us negative 4 on the top over 4, or a negative 1. If we look up negative 1 on that same table we were looking at before, negative 1 is right here, negative 1.0. And notice that the probability that corresponds to it is 0.1587. So I'm just going to put that. I'll put a little space in there so we know those are not part of the same thing here. All right, now, so we actually had 2 z-scores and 2 different probabilities that we looked up on the table. When we have the word between in our problem, that's exactly what we're going to do. 2 z-scores, look them up on the table, and get the 2 probabilities. But we're looking for an answer that is 1 probability. When we've got these 2, all we're going to do is subtract them to get the probability that Robin's score is between those 2 scores, 18 and 20. And if we put that into the calculator, we get 0.1498. All right, now one last problem, and then we're going to look at how we can use Excel instead of using the tables to find our probabilities. So, what number of points would Robin need to score in the next game to be scoring higher than 90% of his games? So we're going backwards here. Notice we're not given an x value. We're not given a score as we were in the past 3 problems. We're given the probability, or the percentage here, the 90%. So we're going to kind of go backwards with our z-score. But I'm going to give you an easier formula to deal with when we go backwards. So, and I'm going to write it out like this so it'll be easier for you to think about. So here is our backwards formula, and it's really the same formula we've been using for a z-score, but it's solved for x. You don't need to solve it for x, though. You can just write it down and use it. So let's notice here, first of all, though, we're given 90%, and we don't know what z is. What we're going to do is go backward in our table. 90% as a decimal is 0.90. I'm going to go back to my table, and within the body of this table, I'm going to find the closest thing I can to 0.90. And let's notice right here, here's the closest thing, 0.9032. If I look over here, across from it, the z value is 1.3. So we're going to use 1.3 as our z value and plug into this formula. Our average was 22 from above. 1.3 was our z value, and our standard deviation from the other problems was 4. And we just let our calculator do that, and we get 27.2. So he needs about 27 points in order to score higher than 90% of his other games. All right, now, I said I was going to show you also, rather than using the table, how to find these probabilities using Excel. Now, let's note just one thing. Whenever we look something up on the table, it and what we're about to get out of Excel are the same thing. So, let's say I've done my z-score right here. I've got my negative 0.5, and I want to use Excel to find this probability, this 0.3085. I've already got Excel open. So all I'm going to do is the following command, equal norm.s.dist, close it. I'll put in the z value. We just got negative 0.5, and then the word true, and close it. And hit enter. And notice that it gives me exactly the same probability that we found in our very first question, except Excel takes it out more decimal places. It's more accurate than our table can possibly be. So this will actually give us a more accurate answer if we need it. All right, now let's do, for example, the same thing right here for Z equals -1. We got 0.1587 on the table. Let's use Excel. So if we use Excel, equal norm.s.dist, put in the -1 that we got and the word true, and you'll notice it gives us 0.1587 if it were rounded to 4 decimal places, but of course it takes it out a little further for us. All right, now in our very last question, let me go back here for a second. We had to look in the body of the table to find the Z-score that corresponded to a 90% or 0.9. And we got 1.3 when we looked it up on the table. And remember that we had to look in the table and just find the closest value to 0.90 or 90% that we could find. Well, our Excel will actually be more accurate because it will give us the Z-score that goes with exactly 90% rather than the Z-score that goes with 90.32%. So for that command, we use equal norm.s.inv, and we give it the probability as a decimal now, not as a percentage. So it was 90% or 0.90. And notice it gives us 1.281552. Now we got 1.3 from the table, but this is actually more accurate and it's the better value for us to use.